Welcome to this lecture. In the last lecture, we had discussed how to develop use case diagrams, and given a specific problem, how does one go about developing use case, and we said that we need to practice that with several examples and exercises to get some insight into how to develop the use case model and to document it. In this lecture, we will discuss about the class diagrams. In the class diagram, we document the entities with common features, that is all the objects in a problem which have similar attributes and operations, they constitute a class. For example, in a library system, the book objects have similar attributes and operations. For example, each book has a name, an ISBN number, and so on, and each book has similar operations like issue the book, return the book, and so on, create the book, and so on. And each class is represented using a solid outline rectangle with compartments. We will use a solid outline rectangle with compartments, and we will write the name of the class like book at the top compartment. We will write the attributes here, for example, the book name, the author, the ISBN number, etc. And then in the last compartment, we will write the operations, for example, create book, issue book, return book, and so on. But then we do not show all the three compartments always. We might in some cases write only one rectangle containing the name of the class, that is book. Just notice here that the name of the class is singular. We do not name the class books. So, we can have just one compartment with just the class name. We might have the class name and the methods or the operations that are applicable on this book, or we might have all of them together with three compartments. So, this is the representation. Name of the class is window, the attribute name is size, which is an instance of the size class, visibility is a boolean. The operations are display and hide. That is the class name, these are the attributes, and these are the operations. But later we will see that there are some attributes which are not shown, but they are present, we call them as association attributes. As we proceed, it will become clear. As we were saying that the same class can be represented with different details. We might just represent the class name, sometimes we might represent the class name along with the operations on that class, or we might represent the class name along with the attributes and the operations. But then one would ask that when does one use this representation, which is the name of the class, when does one use the second representation, which is the name with the operations, and the full representation using the name, attributes, and the operations. To answer this question, when we start the object oriented design process, as we will be seeing soon that how to go about doing the object oriented design, initially we identify only the class names, that is which are the classes, we identify the class. So, in the initial stage of the design process, we represent the classes using this representation. As we proceed with the design steps, we assign the operations to the classes, and then we know about which classes have which operations, and in that stage of the design we represent using the class name and the operations, and towards the end of the design we identify the attributes that the classes should have, and that is why these are more complete and can be easily translated to code. The class name, what are the attributes of this, or the class member, and then the methods of the class. So, to start with the design process, as we start, we use the simplest representation, because we identify only the classes, and much later in the design process we identify the operations that for each class, and we use this representation, and towards the end of the design we have this complete representation, and this can be easily translated to code. Now, let us answer this question, that in any object oriented implementation there are many classes, many objects from which we construct the classes. Now, a typical software might have a dozen classes or maybe several dozens or hundreds of classes, but the classes are not independent, the classes are related. What are the possible relations that can exist among the classes? Actually, there are 4 types of relations that may exist among the classes in a system. The first type of relation is inheritance. One class may be inherited from a base class. So, the base class can, from the base class we can inherit a derived class. Between two classes an association relationship may exist. Please give an example of an association relationship between two classes. In couple of minutes we will just see some examples of association relationship between two classes. There may be an aggregation or composition relationship between two classes. If you can give some example regarding aggregation or composition relationship between two classes, some realistic examples, that will be really nice. Otherwise, in couple of minutes we will see some examples of aggregation and composition relationship and what is the implication of this with respect to the implementation of the software. The fourth type of relation between classes is dependency. So, one class may depend on another class. We will see a short while from now that when does a class is said to depend on another class. We will see that there are various reasons why a class may be dependent on another class. Now, let us see these 4 types of relationship in some detail. First, we will look at the inheritance relationship. Inheritance is a powerful mechanism in object orientation. It allows us to define a new class called as the derived class by extending the base class. Using the inheritance, we can represent the generalization specialization relationship. The base class is the general class and the special class, the specialization classes, they add few more attributes or methods to the general class. While we can add few more attributes to the general class, but we can at the same time redefine some of the existing classes, that is called as overriding, some of the existing methods of the base class, and that is called as overriding. Just look at this example. The library member class is a base class. There are different types of library member, but some characteristics are common among them. For example, all of them have a library membership number. All of them can issue certain number of books, they can return book and so on. So, the common characteristics among different members here are represented as the base class, and the faculty, student and staff. These are the child classes or the derived classes, and each of these add few more attributes and operations to the base class. And we have another hierarchy here, that the students can be undergraduate student, postgraduate or research students. So, the characteristics that are specified here in the student class, that is the method and attribute, are all shared, or all of these classes here, they have those same characteristics, the attributes and methods, but each of these add few more attributes and maybe methods. This is an example of inheritance. A dog is an animal, a cat is an animal. We have underlined the is a here to denote that sometimes the inheritance relation is also called is a relation. Animals, we know they have some characteristics, they are living, they take food, they die, etc., and those characteristics are all shared by the different animals. So, a dog is an animal, a cat is an animal, and therefore, sometimes the inheritance relationship is called as the is a relationship. A derived class inherits the attributes of the base class, and this helps in reusing the code. The library member may have some attribute and method, we do not have to repeat those, rewrite those again in all these classes. These are automatically inherited when we use the inheritance mechanism, and that helps in code reuse. We can have multiple inheritance in which a class may inherit from two base classes. So, the research student has the characteristic of a student and also a staff. So, this is called as the multiple inheritance. Now, let us see how inheritance relations can be implemented in Java. Of course, if you are familiar with other object oriented programming languages, that will be very similar to here, just a small change in the keywords and so on, but the concepts are very similar. Let us assume that this is the class hierarchy that we have in our design. A person is a class, and we have name and date of birth as the attributes, and employee is a derived class. Employee is a special type of person. So, this is a general class, this is a special type of person, is an employee, which has not only the name, date of birth, it has few other attributes as well. For example, employee ID, salary, start date for the employment and so on. How do we write the Java code for this? That is very straightforward. We write the definition for the class person, which is private string name, private date of birth. So, straight away we can translate this into the code. Similar is with C++ or any other object oriented language. And for the derived class, we use the keyword extends in Java. The class employee extends person, and if we write extends, then automatically name and date of birth are inherited by the person class, and we have few attributes that are defined here. We write them here: private employee ID, private salary, private date start date. So, inheritance implementation is straightforward. We have a keyword extends in Java, and we can very easily implement such a relationship in Java by simply using the extends relation. But we will see that the other type of relationship between classes like association, aggregation and so on, we do not have a single keyword using which you can implement those relations. We need to do something else, but it would have been nice or very simple if we just had a keyword like extends. This is the simplest implementation of a relationship by just using a keyword. And once we create the two classes here, employee class, we can instantiate an employee class into objects, right? We write employee, an employee is equal to new employee. So, the new keyword helps us create the object of employee class, and the name of this object is an employee. Let us say we have we want to create objects myRectangle and myBox. We have the classes rectangle and box. Now, we want to create objects myRectangle and myBox. We write rectangle myRectangle is equal to new rectangle, and we give the dimensions of the rectangle 5, 3 as the argument to this constructor, and box myBox is equal to new box, and we give the arguments here. So, when we create this, we write new rectangle 5, 3. The attributes in this object are assigned the value 5 and 3, and once we write the new operator, that is we create an instance of this class, we get a handle here that we call as the identification or the identifier of this object. Normally, we call it as the object reference. So, my rectangle, once we say new rectangle 5, 3, my rectangle is the object reference or the reference for this object that we created. Similarly, once we say that my box is equal to new box, my box becomes the object reference for the box object, but the box object is a inherited object. It is a derived class and it inherits the attributes and methods of the base class, and therefore, implicitly we can think that the attributes length and width defined in the base class are also present in the derived class, and we have this new attribute which is added here is the height, which is also present. So, this is another example of a generalization specialization. There is an example of a multiple inheritance. The feline class inherits from both mammal and quadruped, and then from the feline class we have the tiger, lion and puma as the derived classes. Lizard is derived from quadruped. Suppose someone has drawn this inheritance relationship. Chassis, engine and door are derived from class. Is this correct? Does it appear all right, this inheritance hierarchy, that chassis, engine, door are derived from the car class? No, this is not correct. It is a wrong generalization. We had said that the inheritance relationship we characterize by EJ relationship. We cannot say that chassis is a car is not a chassis. Engine is a car is not a proper generalization, and similarly door is a car is not a proper generalization. So, this is not a proper generalization specialization relationship, and we cannot represent it using a inheritance relationship. Later we will see that this is actually an aggregation relationship. So, to check whether the relationship is correct or not, we can use this test, that we can say that whether a chassis is a car, engine is a car. If it is a general class and these are special class, then the EJ relationship would hold. For example, a library member, UG member, PG member and staff member, can always say a UG member is a library member, a PG member is a library member, a staff member is a library member. So, the EJ relationship holds, here it does not hold. So, this is a wrong construction of generalization specialization relation between these classes. We often have many classes derived from a base class, but it is a good idea to use a discriminator based on which these derived classes are defined. For example, these the library books can be issuable books or reference books. So, it is a good idea to write the discriminator based on which this set of classes are derived and this set of classes are derived, that helps in readability and is supported by UML. To write the discriminator while constructing a complex class hierarchy, that helps us to understand the hierarchy better. Inheritance is a powerful mechanism, promotes reuse, simplifies the design and also easily implemented in code just by using a keyword. But in spite of its many advantages, if we indiscriminately use inheritance, it will result in poor quality of programs. For example, if we have a very deep class hierarchy, then it is has poor cohesion and coupling, because a large number of methods are visible in the leaf classes, and that leads to tight coupling, and it makes it very difficult to understand the leaf classes, because they have too many methods and we need to examine what are the methods it has inherited. So, inheritance should be used with some caution. Now, let us look at the second type of relationship between classes. This is the association relationship. We need to discuss some examples of association relationship, and also we need to answer this question that how are these implemented in a program. In case of inheritance, we saw that there are simple keywords in all object oriented languages, whether it is Java, C++ or any other language. The inheritance relationship is straightforward to implement, but how does one go about implementing the association relationship? One thing that we must remember about the association relationship is that when two classes are associated, the corresponding objects can communicate with each other. As we will look at the examples, it will become clear. One class can invoke the methods of another class, but to be able to invoke the method of another object, the object must somehow store the ID of the other object, otherwise how will it invoke the method of the other class, and that holds the idea of how to implement an association relationship. We will soon look at that. The association relationship is usually binary, but it can be a higher degree association like ternary, or in general can be n-ary. Let us look at an example of an association relationship. Let us say a VCR, a video recorder, is associated with a TV, and we can have a remote which is associated with the VCR. So, we can the remote object can give command to the VCR can record what is being played on the TV. So, the TV object is associated to the VCR object, because the VCR object receives signal from the TV object, and the VCR may in turn be associated with a remote, and it can receive command from the remote. The way we represent the association relationship is by drawing a line. There are different ways we can draw the line. Sometimes we draw an arrow, sometimes we just write this line. We will see when we draw an arrow and when we draw a line, and we write here the multiplicity and we write the reading direction here. We will see the details of how to represent the association relationship, what are the implications of just drawing an arrow, just drawing a line, and then we write the name of the association here on this line or arrow, and we write the reading direction. Say that the VCR is connected to TV, it helps us to read, or we can read the TV connects to the VCR. The remote commands to the VCR, or we can read as the VCR receives commands from the remote. So, we have reached the end of this lecture, and we will continue in the next lecture to discuss about how to represent the association relationship, the multiplicity, and so on as per the UML syntax. We will stop here and continue in the next lecture. Thank you.